if you're doing a vigorous intensity exercise, 10 minutes, that's all it took was 10 minutes to have improvements in cognition, executive function, processing speed. These researchers took these older adults and they put them on a year-long intervention exercise program. And after that year, they had a 2% increase in their hippocampal volume. A part of the reason that happens is so there's what I like to think of as there's definitely big movers. There's things that require effort, and there's like lower hanging fruit. And I would say the big movers are the ones that, of course, are going to require more effort. Like that's always how it is, right? It's pretty clear now. I think it's pretty scientific consensus that exercise, and particularly vigorous exercise, is one of the best ways that you can get a cognitive enhancement. You know, memory, executive function, processing speed. So there have been studies that have been done in older adults, in middle-aged adults, in children, like across the lifespan. And it's just undeniable that getting your heart rate up, getting your heart rate up and blood flow up and sweating is going to make you smarter and feel better. It's going to make you both. There was even one study that was done in older adults. These researchers took these older adults and they put them on a year-long intervention exercise program. And there was a lot of more vigorous intensity. So they're getting up to about 80% max heart rate, 80% max heart rate. And for 1 year, they did this intervention. And after that year, they had a 2% increase in their hippocampal volume. Hippocampus is a part of your brain that's highly involved in learning and memory. And they had increased it by like 2%. So people that in that age group lose between 1% to 2% of their hippocampal volume per year. So they essentially countered that loss, that atrophy that they're age-related, experiencing each year. And so part of the reason that happens is when you're doing a vigorous type of exercise, you are increasing brain-derived neurotrophic factor, BDNF. And that is responsible for growing new neurons in the hippocampus. It's responsible for neuroplasticity. So that's the ability of your brain to adapt and change to the changing environment, which is what older adults don't do very well, right? Your brain's much more plastic when it's younger. You can adapt to things. So BDNF plays a role in that. So you want more BDNF, and exercise, and particularly vigorous exercise. If you're working your muscles so hard that they can't get oxygen to them fast enough, and that's why I say vigorous, then they're forced to basically make energy without oxygen. And that happens by just using glucose. Then you make lactate as a byproduct. And lactate is what is signaling and increasing that BDNF. And if you're doing a vigorous intensity exercise, 10 minutes, that's all it took was 10 minutes to have improvements in cognition, executive function, processing speed. So you just can do a 10-minute workout. It could be high intensity interval training where you're shifting between periods of vigorous exercise and then kind of resting a little bit. And then you do these intervals. Or it could just be I'm going to do a 20-minute run and then I'm going to go, I'm going to do it. The question is, well, how hard do I need to go on the endurance? So does it need to be more of a vigorous exercise workout or moderate intensity, lower intensity? Is anything better than nothing? I think at the end of the day, the most important thing is habit. What are you going to consistently do, right? You're going to consistently do some sort of physical activity, and it needs to be that, whatever it is that you will do. Otherwise, you can talk about what's the best, but if you won't do it, it doesn't matter, right? If you are not an athlete doing more than 10 hours a week, or 10 or more, right, of, endurance training. If you're not that person, the data suggests it's more beneficial to engage the majority of the time in more vigorous intensity exercise versus what's zone 2 training, right? So a lower intensity or the talk test kind of exercise, right, where you're breathy, but you can still have a conversation. If you are going harder and you're getting that heart rate up to 80% max heart rate, you're increasing that lactate. And we've talked about this, that in itself is beneficial. It's beneficial for the brain. And so lactate's been shown, lactate is consumed by the brain during physical activity. This has been shown in humans. And it fuels basically neural function while you're exercising. So your brain is working harder while you're exercising, just like your heart and your muscles. Your brain is working harder too. And lactate is fueling that. And you're basically increasing norepinephrine and serotonin from that lactate. So lactate itself, it can be used as an energy source. Lactate increases those neurotransmitters. It also increases that brain-derived neurotrophic factor, which is beneficial for growing new neurons. It's beneficial for neuroplasticity, for basically making you feel better, making you smarter, staving off neurodegenerative disease. You want BDNF, that's what you want. This is all evidence-based studies that have been shown in humans, showing that the higher intensity, the more intense the workout, the more vigorous, the more lactate lactate, and lactate is signaling to increase that. And it's the way that your muscles communicate with other organs. Like it's increasing lactate, and lactate is it's being shuttled to other organs, and it's signaling to them to do these beneficial things. So the lactate itself is only going to come when you're cranking up the intensity, when you're working hard enough that you can't get enough oxygen to your muscles, to basically produce energy. That's sort of I'm actually trying to make more lactate. The lactate increase doesn't last long. It's pretty transient, like 20 minutes or so, you'll be back to your baseline after a pretty intense workout. There's data not only showing that it's beneficial for the brain and brain-derived neurotrophic factor and these neurotransmitters I was talking about, but also lactate itself is used by neurons. So the lactate that's going into your brain, it's transported across the blood-brain barrier. It's used by neurons as an energy source. And in fact, our neurons prefer lactate. Definitely the thing that you want. There's some evidence that like doing this vigorous exercise is important, but it has to be like a longer interval type of exercise. At least 1 minute, that would be sort of the minimum, but like better if you can get to 4 minutes. So there's something called the Norwegian 4x4 protocol. And that's 4 minutes at the highest intensity that you can maintain for that entire 4 minutes, followed by 3-minute recovery of like light exercise. I mean, you want your heart rate to come down so that you could do it again 4 times. The Norwegian 4x4, there was a study, the study took 50-year-olds that were healthy, but they were not physically active. And they put them on a pretty intensive training protocol for 2 years. By the time they got to their 6-month mark, they were doing about 4 hours a week of what's called maximal intensity exercise. It was like as high as you can maintain vigorous intensity workout for 30 minutes, basically. They were doing exercise 4 hours a week. They were doing, a majority of that was maximal intensity exercise. And then they were also doing some strength training. And then they were doing the Norwegian 4x4. So after 2 years, these people, like the cardiac structure, so as we age, our heart gets smaller and it gets stiffer. This happens, it's like part of aging. That results in a lot of things. So cardiovascular disease risk goes up, but also like your exercise performance and capacity goes down. So after that 2 years of, doing this pretty vigorous intensity exercise protocol, the 50-year-olds, they reversed their cardiac structure aging by 20 years. So their hearts were looking more like 30-year-old hearts versus 50-year-old hearts. And this is after 2 years of doing this.